Hello everyone, welcome to my mini lecture on exponential graphs. Now exponentials have the general form that you see on the screen there, which is y equals a e to the kx. So if we have a look at the most simple exponential function, that is y equals e to the x, which is y equals 1e to the 1x. So that's the equation that has a and k both being 1. And we see that the curve of y equals e to the x is in red there. It's an ever increasing function, and it has an asymptote, which is a line it never crosses. So it never goes below the blue line there. Now on this left-hand side, it gets very close, but it never actually crosses that line. It's just like if you started with 1 and then you kept on dividing by 2. So you've got 1, then a half, and then a quarter, then an eighth, and so on. Your value is getting smaller and smaller, but you're never reaching 0. It's the same thing with an asymptote. It approaches the value, it approaches 0, but it never exactly reaches 0. So that is the graph of e to the x. If we consider e to the x plus 1, so now we've added on a plus 1, just like what we spoke about in Parabola's mini lecture. If we add a 1 to a function, that has the effect of moving it up by 1 unit. So it moves the red curve, which is the actual e to the x graph, up by 1 unit, and it also moves the asymptote up by 1 unit as well. If we look at y equals e to the negative x, so we've now made k negative, that has the effect of taking the mirror image of the graph. And that's quite common throughout the whole graphing topic. If you replace all of the x's with negative x, so you put a negative in front of all of the x's, then that gives you the mirror image of the original graph. And if we put a negative sign in front of the whole function, so negative e to the x, so now we're making a negative, that has the effect of flipping the graph upside down. So that moves the exponential graph down below the x-axis, and it's still trending away from the x-axis as it heads to the right. Now let's look at a couple of equations. So here we have the graph of some function. We know it's exponential, and because it's decreasing exponentially but still above the x-axis, we can tell that a is going to be positive but k is going to be negative here. This is a typical kind of question. We have 2 points that the graph goes through, and we need to find what the equation of the graph is. In other words, find the values of a and k. So our starting point is going to be our general equation, which is y equals a e to the kx. Now we have 2 points that it goes through. We'll start with the y-intercept, which is 0, 2. So if we substitute 0, 2 into y equals a e to the kx, so y is 2 equals a e to the k multiplied by 0, because we're putting in x is 0, y is 2. And in that power of the exponential, so we've got 2 equals a e to the k times 0 is 0, and also e to the power of 0 is 1. So we've got a times 1, so therefore a times 1, which is just a, equals 2. So we have found already that a equals 2, and if we substitute a equals 2 into our equation, so we'll take a equals 2, put that back into y equals a e to the kx. That tells us that so far we have y equals 2e to the kx. Okay, so far so good. We just need to find the value of k from here, and we have one other point that it goes through, which is the point -1, 6. So when x is -1, y equals 6, and if we substitute that into y equals 2e to the kx. So we'll substitute that back into this equation. 0, 2, we substituted into your y equals ae to the kx originally. And if we do that, what we're going to end up with is y, which is 6, equals a is 2, e to the k multiplied by -1. And we need to solve that for k. So logarithms are going to come into play here. First thing to do would be to divide through by 2. If we divide that equation by 2, we get 3 equals e to the k times -1 is just -k. And we need to get rid of the e next. To get rid of e, we need to take ln of both sides. So this gives you a bit of a revision of logarithms as well. So since we're getting rid of an e, we need to take ln of both sides. And on the right-hand side, we're going to be left with -k. And therefore, if we multiply that equation through by -1, we therefore get k is -ln of 3. And if we calculate that, we get -1.10. So our equation is y equals, we'll put that value of 1.10 back into our y equals 2e to the kx. So we get 2e to the -1.10x is our equation of that graph. Okay, so we have one more question to find the equation of. So we've got 2 points that it goes through again. One is the y-intercept. You will usually, in fact, you will always be given the y-intercept and one other point. So we've got y equals ae to the kx, and we start by substituting in the y-intercept, and then we will get our value of a, just like what we did with the last question. Putting in 0, we get x equals 0 and y equals 0.5. We get 0.5 equals ae to the k multiplied by 0, and k times 0 is 0, so we've got 0.5 equals ae to the 0, and e to the 0 is 1, so we've got 0.5 equals a. So 0.5 is our value of a, and we can put that back into y equals ae to the kx. So we have y equals a, which is 0.5 e to the power of kx. Okay, so we've got the value of a. Now we need to put the other point, which is in this case 2, 2, into y equals 0.5 e to the kx. So here x and y are both 2, so we've got 2 equals 0.5 e to the k multiplied by 2, and we need to solve that for k. Okay, so first thing to do would be to divide by 0.5. So 2 divided by 0.5 is 4. So we get 4 equals e to the power of 2k. And then we need to get rid of the e. So we can do that by taking ln of both sides. So we get ln of 4 equals 2k. And then we can divide both sides by 2. So we get k equals ln of 4. And that's divided by 2. Calculating that, we get a value of 0.693, and our equation is y equals 0.5 e to the 0.693 times x. So that's our equation, and that concludes the mini lecture on exponentials. Next one will be on logarithm graphs. Thanks for watching.